So we've seen formulations for two different examples, the clothing example and the Galaxy toys. Both were product mix. Both were very simple because they only had two variables. So the next thing we want to do is actually try to solve these two problems using Excel. So we're going to be using the solver add-in in Excel. It's furnished by Frontline Solvers. They do make a real industrial strength solver. The one that comes with Excel for free, however, has limitations. You can only have at most 200 constraints and or variables within a problem. For us, we probably won't run into that problem or that limitation with the examples that we look at in class. And then what we want to do is within Excel, within a worksheet, each column is going to be a variable. And then we'll have each constraint be its own row. So here is what we're going to try to end up having for shirts and pajamas for the clothing manufacturer. All right. So let's try using our formulation from before and put it in Excel and then solve it. All right. So let me go to Excel. Here's a blank workbook, worksheet. So we're going to have our output, and we called it x sub 1 and x sub 2 so in the formulation. So we'll do the same thing here. We have an objective function subject to constraints, and the constraints we had were cutting hours and sewing hours, right? So now I'm just going to make it a little bit prettier, center all that. So this is the output is the output of the LP. So I like to put that at the top so that we can see it a lot easier when we finish up. And I like this blue accent 1 color for the output. And then the objective function, we put within the cells under X1, it was $4 for each shirt, and then $3 for each pair of PJs. Right, so that's the objective function right there. Subject to, we had cutting. It was 1.5 hours for a shirt, 2 for pajamas, and we needed to stay under 450. All right. And I left column D blank on purpose. We'll come back to that in a minute. Sewing was a 1. We have to put the 1 there, right? If we leave it blank, it thinks it's a 0. And then 0.75, and then less than or equal to 280 in this case. All right. And then, so now what we need to do is we need to set up LHS stands for left-hand side. RHS stands for right-hand side. The right-hand side has to be a number. All right? That's why we put everything in standard form. So that's what the Excel solver is expecting us to look for. The left-hand side over here, though, actually needs to be a function, a formula. And it has to be a linear function or formula. So it cannot be something like an if statement. So what we want to do here is, how do I make sure I stay under 450? We would do 1.5 times the number that comes out for x1 plus 2 times what comes out for x2. So we could do that manual formula, but there's a better formula to do, which we've seen before in the class, sum product. It takes in 2 arrays. I'm going to do the first array of the variables and make it absolute reference. And then the second array is going to be the coefficients for the cutting hours, which is in row 6. And close parenthesis, enter. So now the question is this doing what it's supposed to do? So if I put a 1 up here in X1 and hit tab or enter, what will show up in D6? It better be 1.5. Okay, good. Well, now if I put a 1 over in X2 and keep the 1 in X1, then we better add 2 more, so it better be 3.5. Okay, it looks like it's doing what it's supposed to do. If I put a 2 here, it should go up by 2, go up to 5.5. Okay, so the sum product function looks like it's working properly. And now I ought to be able to drag it down because I anchored where the output was, the variables. Right? So again, when we add the constraints, we have to have a formula for the left-hand side, and we have to have a number, excuse me, for the right-hand side. Now the only thing we haven't done yet is come up with the objective function, and again, this can be a sum product of our decision variables with our objective function coefficients. And I'm going to highlight that in blue as well. Right? So if I put a 1 here, my profit goes up to $4. If I put a 1 here, my profit goes up to $7. Right? And then I like to start at 0, 0. So the only thing I have not put on here that we had in the formulation was the non-negativity constraints. We do not have to explicitly list them as a constraint. There is a nice little feature in the solver that allows us to just simply tell it that we need non-negativity. So that's what we'll do instead. So now we're ready to go to the solver. So I'm going to go Data, and over under Analyze we should have Solver. If you don't have it, then you have to go to your Options and manage your add-ins and make sure that you have it. All new versions of Excel do have it, even for a Mac. And so set the objective. That's our objective function, the one that has the sum product in it. It's pointing to A9 because that's where that's the cell I had selected or highlighted or active, right? That's not right, so I'm going to come over here and pick F2 in this case. I'm maximizing. We're only going to use max or min. We're maximizing. By changing the variable cells, these are the ones I highlighted in blue, B2 and C2. Right now they're blank, so it thinks they're 0. That's why we have a 0 here in F2. Subject to constraints. Click Add. And cell reference is the left-hand side. That's the thing that has to be a formula. In our case, we're going to primarily use sum product. We might just use sum at some times, along the way somewhere, but sum product is the one that we normally use. We have in the middle here the less than or equal to constraint, less than or equal to inequality sign, which is what we want. And then the constraint is going to be the right-hand side or the numbers, in our case 450 and 280. Now, I can add both of these constraints at the same time because they're both less than or equal to constraints. So to do that, the cell reference, I just select D6 and D7. It's still less than or equal to, and on the constraint for the right-hand side, I select F6 and F7 and click OK. When I do that, I see that there's only one line here, but that one line represents 2 constraints. I can do this because they are both less than or equal to constraints. So when you're doing new problems, it might be beneficial to put all the less than or equal to constraints next to each other, all the greater than or equal to constraints next to each other, so you can add them all at the same time in chunks, basically. All right. Then the next thing we need to do is right here, make sure this checkbox is checked. Make sure there's a check mark there. Make unconstrained variables non-negative. That's my non-negativity. This is why I don't have to put in explicit non-negativity constraints onto the spreadsheet. I just check this box off. And then, most importantly, we need to select this solving method, and it's not the one that comes up by default. It is, instead, the one in the middle, simplex LP. LP stands for linear programming, or linear program. Simplex is the algorithm that it's using in the background, right? And down here, it'll remind you, right, select the LP simplex engine for linear solver problems. That's what we're doing. We're doing linear programming, so we have to choose the LP one. And then we ought to be able to just from here click Solve. So we click Solve, and it says Solver found a solution. All constraints and optimality conditions are satisfied. Woohoo! That means we found an optimal solution, the best, right? And then we have the option to kick out some reports. So let's kick out all 3, answer, sensitivity, and limits, and click OK. Right. So here we see the results we should make 280 shirts and 0 pajamas next week for a total profit of $1,120. Right? Down here we can also see that cutting hours, we're using 420 out of the 450, and sewing, we're using all 280 that we had available to us. So let's go look at the reports just briefly. The answer report tells me how long it took, right? What engine it was, the options that we did not go look at because we don't need it for this problem. And then it says the objective cell was called output. It started at 0, yes, and the final value is 1120. Variable cells x1, x2 started at 0 because they were blank, finished at 280 and 0, and they are both continuous variables. Again, that's the visibility assumption that we're saying we're okay with for this particular unit. And then the nice thing about the answer report is down here, cutting hours and sewing hours, it tells us the final value, 420 and 280, and then it tells us the status of binding or not binding. So binding means that I'm using up everything. So I'm using up all of my sewing. There's no slack left over. That's the 0. Not binding is telling me the cutting hours, I have not used everything up. There's slack. I have 30 hours left over. Right? So if I were to throw more resources or money at this, would I put more effort and resources into cutting or sewing? The answer should be obvious. I'm not using everything for cutting, so why would I put more resources there? Instead, I'm using all my sewing, so I would add more resources to sewing hours. I'm going to skip the sensitivity report and go over to the limits report. I hardly ever use this in practice, right? So you can look at it and see if it makes any good sense for you. Again, I think I can get everything I need from the answer in the sensitivity report. Then we have the sensitivity report, and we will go through this in much more detail in later videos. All right, we got variable cells and constraint, so we have 2 different areas to it. And again, we will go over this in a lot more detail in some future videos.